4.6. Okay, if I had this x squared is equal to 16, and I take the square root, there was a trick we had to do every time we square root an x squared. What was it? No. So think back to the original. Certainly the answer is 4, right? But think about it. What number times itself is 16? 4 and negative 4. So anytime you square root an x squared, you have to put plus or minus on the other side. Okay? That's one of the rules of square rooting. Now, let's do a problem that's kind of similar. X squared is equal to negative 9. So I take the square root, and I get x equals plus or minus the square root of negative 9. What number times itself is negative 9? Oh, no, you're on your phone again. That hurt your grade. Oh, you and getting ahead. Oh, all right. You're good. Sorry. Oh, good. We cannot. So now that I have accused somebody wrongly, I apologize. Back to math. So what number times itself is negative 9? There isn't one, right? 3 times 3 is 9. Negative 3 times negative 3 is still 9. So what about 3 times negative 3? That's not the same number, right? So for a very long time in mathematics, we just said no solution. But it turns out that that's not a good enough answer for a lot of reasons. And those reasons I did not fully understand until I had taken many years of mathematics in college. So just trust me, it is necessary that we create numbers that satisfy this equation. So what we have done is invented a number, the square root of negative 1. And the square root of negative 1 is not a real number. Now, that doesn't mean it doesn't exist. It means it's not found on the real number line. So the number line with 0 in the middle and it goes to infinity on both sides, that is called the real number line. And anything that is not on that line is considered not a real number. For instance, infinity. Infinity is not a real number. It's more of an idea. So the square root of negative 1 is not a real number, and we have determined to call it an imaginary number, not because it's fake, but because it's not real. And so we have defined it as I. I is a number, kind of like pi or e. It's not a variable, it is a number. And so I is equivalent to the square root of negative 1, which allows us to take this and split it into plus or minus the square root of 9 times the square root of negative 1. So we split the negative from the rest of the number, and this we know, it's just 3, and this is I. So what number times itself is negative 9? 3i. Yeah. It's an imaginary number. 3i. Now, let's see if that's actually true. Let's do 3i times 3i. Well, that would give me what? 9i squared. Well, what is I squared? This is a little bit tricky, but if I come over here to this equation and I square the right side, then I have to square the left side. And what is a square root squared? It's just the stuff on the inside. So I squared is negative 1, which means this turns into negative 9. So 3i times 3i, (9i squared). I squared is -1. And so 3i squared is -9. So we now have a way to take the square root of a negative number. It's a little bit weird, but that is the answer. Now, we have real numbers that are found on the number line. We have imaginary numbers that are include i's. What happens when we try to mix real and imaginary numbers? So let's say we have 3 and we're going to add 4i. Well, they're not like terms. They cannot interact. So 3 plus 4i cannot be simplified. So this piece is real, and this piece is imaginary, and together we call them a complex number. So complex numbers contain real pieces and imaginary pieces. Now, we actually kind of use these interchangeably. Sometimes we call this an imaginary number, and sometimes we call it a complex number. But technically, if you hear imaginary number, that is just the I portion, not the real portion. And if you hear complex number, it means a real portion and a complex portion. Now, having said that, if I had 0 plus 3i, is that a complex number or an imaginary number? It's kind of both, right? And if I had 4 plus 0i, that's a complex number, but it's also a real number because there's no I portion. Okay? Yeah, kind of weird. So, first thing we need to do is simplify square roots with negatives. So if I had the square root of -36, what does that equal? Well, we square root the 36, which gives me 6, and then I square root the -1, which gives me I. 6i. Okay, yep, that easy. What about negative square root of 25? What does that equal? -5, good job. Why isn't there an I? The negative's on the outside, so that would just be -5, okay? What about negative square root of -64? -8i, good job. -8i. Got it? Okay. What about the square root of -24? That one doesn't come out evenly, but I can factor it. And if I factor it, I get 2 times 2 times 2 times 3. What can I bring out? Set of 2's. So I put 2, and what's left on the inside? 6. Where do I put the negative? Where do I put the I? So I's always come after numbers, after variables, but before square roots. So if I had 6x square root of 3z, and I needed an I, it would go right here. Behind the numbers, behind the variables, but before the square root. So in this case, we put the I right there. Okay? All right, next step. What happens when we add imaginary numbers together? So let's say I had 4 plus 3i. That's a complex number. We're going to add that to -7 minus 6i. Well, the real portion can only affect the real portion, and the imaginary portion can only affect the imaginary portion. So this is just like combining like terms. Does 4 have a match in the other side? So 4 minus 7 is -3. Does 3i have a match on the other side? -6, so we get -3i. And that is considered one complex number. It has two parts. but it is one complex number. Okay. What if we had 2 minus 6i minus 4 minus 5i? What would the real portion be? Not 6. 2 minus 4 is negative 2. So 2 minus 4. And then negative 6 plus 5. Negative 6 minus negative 5 is the same as plus 5. So negative 1i. I don't need the 1. I can just put I. Okay? No. You guys understand that? Okay. Now, this one's a little bit harder. Now we're multiplying. So we can set it up in the box, or you can just distribute if you'd prefer. So 4, 2i, 7, negative 6i. 7 times 4 is 28. 7 times 2i is 14i. 4 times negative 6i is negative 24i. And negative 6 times 2 is negative 12i squared. Now here's where you got to be careful. Do we have any like terms? These go together. So I have 28, and then 14 minus 24 is negative 10i. And then I have negative 12i squared. But a minute ago, I told you what I squared was. Money, you might want to watch this. I squared is the square root of negative 1 squared, which is just negative 1. So anytime you have an I squared, you replace it with negative 1. And what does that negative 1 do to the negative 12? Turns it into plus 12. And now those are like terms. 28 and 12 becomes 40. So when you're multiplying complex numbers together, you multiply them just like you normally would, but right here, your I squared term always becomes negative 1, which will change the sign of that term. Do you want to see another one of those? Okay. So negative 3 plus 2i and 1 minus I. So we set up the box. Negative 3, 2i, 1, negative 1. Negative 3, 2i, 3, negative 2i, I squared. So what happens here? Negative 2 times I squared, and I squared is negative 1. That's just going to become plus 2. So those go together to create negative 1, and these go together to create 5i. So when you multiply those together, you get negative 1 plus 5i. Okay, that is it for